Hello statistics students, this is Jamie Emigh, and this video is on our discussion of section 8.2, testing a claim about a proportion. Let's start with an example. A poll of 1,068 adult Americans revealed that 513 of those surveyed prefer the Democratic candidate for the presidency. At the 0.10 level of significance, test the claim that at least half of all voters prefer the Democrat. All right, I want to show this example with the critical value method and the p-value method side by side so you can see the similarities and the differences. They both start out the same with two capital H's. First one gets a sub 0 for the null hypothesis, and the second one gets a sub 1 for the alternative hypothesis. Okay, then they both get a colon. And now it's time to make our first decision. We have to decide whether we're going to put a lowercase p, a mu, or sigma. And since this question is about proportions, you can tell by the wording at least half, then we are going to put lowercase p. Half is a proportion, so. All right, the null hypothesis always gets the equal sign, and time for our next decision. The alternative hypothesis has to have does not equals, less than, or greater than. And the way you decide is by looking at the wording in the claim. You find the inequality, and it says at least half. This one is not as straightforward as our examples from section 8.1, so please pay attention to this part. At least half as an inequality is greater than or equal to. But remember, in our alternative hypothesis, we're not allowed to use greater than or equal to. The options were does not equal, greater than, or less than. That's it. So this claim that we're being asked to test contains this part, what we call equality. And that's this little line right here. Think of it as half of an equal sign. Well, since our claim contains equality, we have to use its complement in our alternative hypothesis. Well, the complement of at least half, or greater than or equal to, is less than. So in your alternative hypothesis, you need to write a less than symbol. Okay, now we choose one number for both, and that is half, so 0.5. And the next step in the critical value method is to draw a graph. We're talking proportions here, so you can put a Z. You can put 0 in the middle. And now it's time to make another decision. Do we want to cut off the left tail, the right tail, or both of the tails? If you said the left tail, good job, you got it correct. The reason we cut off the left tail is because the less than sign that we chose for the alternative hypothesis. All right. That tail is cut off at what we call the critical value, and we're going to find that critical value by running the program inverse norm, which will require the area to the left. Oh, well, we have to figure out what the area to the left is, and it's this little rejection region right here. And that area right there is called alpha, and it is our significance level, given to us as 0.10. I'm going to put the 0.90 on the other side just to remind you that the area under the curve has to add up to 1. Okay, so area to the left of the critical value we're looking for is 0.10. All right, pick up your calculator. Let's do this together. Turn it on. Clear your screen. Hit second. Distributions. Scroll down to inverse norm and open that program. First input says area, so 0.10. If you have a calculator that requests it, mu is 0, sigma is 1. Those are the defaults if your calculator doesn't request it. Paste and run that program. All right, so it turns out that we have a critical value of negative 1.28 I'll put 2, so 3 decimal places. Negative 1.282. A little hard to write it with my finger, so. All right, so that is our critical value. Okay, I want you to notice that we have not even looked at the figures, the digits, the data given to us, the 1,068 adults and the 513 that preferred the Democratic candidate. I like to point this out because everything you see here in red, we were able to come up with before we even looked at those numbers. I want to emphasize that so much that I'm going to switch to blue now so that you can really focus on, okay, I have to do everything up there in red first before I even look at their numbers. All right, now below the blue line, it's time to start looking at their numbers. So we're going to run a hypothesis test on their numbers. So we're going to run what is called the one prop Z test. Just like the program you're used to, one prop Z interval, except that they ended this one in the word test, which is really nice because it reminds us, okay, if we're asked to test a claim, make sure you select a program that ends in the word test. The one is because we're talking one population. The prop is because it's about proportions. Okay, so I want you to hit stat on your calculator again. Let's do this together. Stat, scroll over to tests, scroll down to one prop Z test, and open that program. Okay, the first thing it wants from us is P sub naught, which you came up with in step number 1, 0.5. Next thing it wants from us is the number of successes. In this case, success is considered, test the claim that at least half prefer the Democrat. So success would be considered the Democrat, and so that's 513. Next thing it wants from us is N, which is 1,068. And the last thing it wants from us is to select the inequality that we put in the alternative hypothesis. It looks like this. On your screen, it has the P sub naught afterward. So make sure that one is highlighted. Okay, enter all that stuff, highlighting that less than P naught, and go ahead and calculate it. The very first line output of the output screen is our test statistic. Which turns out to be Z equals negative 1.28. Good thing I brought a third decimal place to compare because it's very close to the critical value, negative 1.285. That's the only value we need from the output screen for the critical value method, but I want to point out that the next line on your output screen is P equals 0.09936. That is called the probability of making a type 1 error, or the p-value. So we're going to need that one for the p-value method. Below that is p hat. That would be our best guess at the actual percentage, or I'm sorry, the actual proportion who prefer the Democrat, which is 0.48. As a percentage would be 48%. And the last line on your output screen is your sample size of 1,068. Okay, but like I said, for now, we're just using the Z equals negative 1.285. We're going to put that on the graph, and it's a little further toward negative infinity than the critical value. It's right about here. And I'm going to write a TS for test statistic. All right, I'm going to put my highlighter on because I want to make sure you guys understand that this method, this critical value method, is the comparison of TS and CV. It's the comparison of the test statistic and the critical value. And I want you to remember that I had to do what was in red first. So I had to do the critical value. That's what created that red region in the tail. Then I find the test statistic and figure out if it lies in that rejection region or on the other side of the critical value, which would be the fail to reject region. Okay. That being said, it is time to make our decision. either to reject the null hypothesis or fail to reject the null hypothesis. And since our test statistic is in the rejection region, we are going to reject the null hypothesis. Okay, now it is time to write our conclusion. We always start with the word there. Okay, first decision as far as writing our conclusion goes. We have to decide if we're going to write is or if we're going to write is not. Since we chose reject, then we write is. Had we chose fail to reject, we would have wrote is not. One way I remember it is fail to reject and is not both have more words. Reject and is less words. So if that works for you, feel free to use that. There is, and then we always say sufficient evidence. Two. Now, next decision we have to make as far as writing our conclusion. We either have to say support or reject. And you may think it has to do with our decision to reject the null hypothesis, but it does not. Choosing the next blank of support or reject goes way back to the beginning of the problem and this at least half part. Since at least half contained equality, this half of an equal sign, that makes our decision for us. That means we have to write reject. Had the claim not contained equality, it would have been something straight to like less than, then we would have said support. And reject and support are complements of each other. So it kind of makes sense that if your claim contains equality, you'll want to use the word reject in your final conclusion, not in your decision making, not to the very, very end. And if your claim does not contain equality, you would put support. Okay, so there is sufficient evidence to reject. And then we, no more decisions to make. We just write the claim that. And then we just restate the claim. At least half of all voters prefer the Democrat. That's not going to work. That at least half of voters prefer the Democratic Party representative candidate. There we go. I'm just going to stop there though because I'm out of room. Okay, I want to do the same problem. It'll be a lot faster this time because it's a lot of repeating what we did before using the p-value method. So they start out the same. Two capital H's, a sub-0, a sub-1. So that's a 1. Colon, p equals p less than. So all of this so far is the same. Okay, it's the graph part that we don't do. What we're going to do instead is go straight to one prop z test, which is in blue. So I'm even going to do it in the same color so you can see it or compare it. And it's going to be the same inputs. P naught is 0.5. X equals 513. N is still 1068. Now, this part right here, if you don't draw the graph, that'll be the hardest part to come up. Oh, Not true. You don't need the graph. You can just use it straight from the alternative hypothesis, the less than symbol that we decided on. Okay, when we run that program, we will get the test statistic. That is true, but that's not the output on the screen we're interested in. The output on the screen, if you just turn your calculator back on, it's probably still sitting on your screen. The output we're interested in is P equals 0.09936 and so on. Okay, what we do now is compare the p-value to the significance level. Which is alpha. And when I say compare, I mean say which one is greater than or less than. So I like to put a box in the middle of the two, and then we're going to write either the greater than sign or the less than sign. Okay, our p-value is 0.09936, and our significance level alpha is 0.10. And so the inequality symbol would be less than. Okay, then we say this little rhyme. P is low. The null must go. And the reason we said P is low is because of this less than sign right here. It's lower than the significance level. Had it been larger, we would have said P is high. The null will fly. And those two little rhymes are in your notes. So P is low, the null must go. So it's time to make our decision. So I'll go to black. And our decision, the null must go. So we reject it. It's gotta go. And then it is time to write our final conclusion. We always start with the word there. We decide between is or is not, and that's based on reject leads to is. Had it been failed to reject, it would have been is not. Then we always say sufficient evidence. Two, now we decide between support and reject. The decision to support or reject goes way back to the beginning. The at least half min greater than or equal to, which contains equality. So whenever our claim contains equality, we use the word reject. These two rejects are not linked. The first one, reject, came from P is low, the null must go. That's the reject. This second reject I wrote comes from the claim and containing equality. And then no more decisions to make, we just restate the claim. At least half of all voters prefer the Democratic candidate. A lot of shorthand there, sorry about that, but I ran out of room. It's quite hard to write with my finger combined with this stylus. Okay, so now you can see the two methods side by side. Some people think, oh, the p-value method's way shorter because you don't have to do the graph. Some people like the critical value method because the graph gives them a visual on the rejection. It's up to you. If they do not specify which method to use whichever one you prefer. Oftentimes they'll ask for parts from both methods though. Like they'll ask, what is the test statistic? And so you'll give them z equals -1.285, and then you can use the p-value method to make your decision if you prefer. But I hope that seeing those side by side helped, and I'm going to move to the next slide now. All right, the National Cybersecurity Alliance reports that 96% of computers have antivirus programs. In a random sample of 400 computers, it is found that 380 of them have antivirus software programs. Test the claim that the percentage of computers with antivirus programs is less than 96%, and specifically they ask us to use the p-value method. Okay, like I've said before, many of these questions in this class and statistics can be very wordy, and you can feel very overwhelmed if you just read that and try to dive into computers and something about anti-virus programs. I don't want you to do that to yourself if that overwhelms you. I want you to take a step back. When you're ready, come back to the problem and figure out what it is they're asking you to do. Are they asking you for a minimum sample size? No. Are they asking you to set up a confidence interval? No. Are they asking you to test a claim? Yes. Whenever they're asking you to test a claim, take a deep breath. Regardless of the problem, you know how to start these. You do 2 capital H's, a sub naught, a sub 1. Then you have to decide between lowercase p, mu, or sigma. This is again about percentages or proportions, so it's lowercase p. Your null hypothesis always gets an equal sign. Your alternative hypothesis, you have 3 options: less than, greater than, or does not equal to, and you find your answer in the inequality part of the wording. Test the claim that the percentage of computers with the antivirus program is less than, and that's strictly less than, so you don't have to worry about using the complement. This claim does not contain equality, so just use the less than symbol. And then 96% we write as a decimal, 0.96. Okay, for the p-value method, you need to compare the p-value method, you need to compare the p-value to the significance level. Let's see, did they give us the significance level? Alpha? They did not, which is okay. It's a good time to point out that the default significance level, alpha equals 0.05. Okay, so we're going to be comparing 0.05 to the p-value. So really, we just need to find the p-value, and we can find that by running one prop z test. Just go ahead and pick your calculator up, clear your screen, hit stat. I'm doing this with you. Let's do it together. Hit stat, scroll over to tests, scroll down to one prop z test, open that program. P sub naught is 0.96. X represents the number of successes. Let me write these on here for you. X represents your number of successes, which successes in this case would be computers that have the antivirus software program, so 380. N would be our total number, which is 400 computers. And the last input that it wants from us is the inequality that we used in the alternative hypothesis, which is the less than symbol. And it looks like this on your screen. Make sure that's highlighted. Go ahead and calculate that. If you're asked for the test statistic, it's that first line, z equals negative 1.02. But this one just said to test the claim using the p-value method. So we are only interested in the output p equals. This is the probability of making a type 1 error. And we're going to compare that to alpha, which is 0.05. All right, we need to write an inequality in between the two, and 0.15 is greater than 0.05. So it is time to make our decision. And the little rhyme, if you like to use it, is P is high, the null will fly. I'll just write that since that covers it up. P is high. What I mean by that, it's larger than 0.05. P is high, the null will fly. Okay, time to make our decision. I'm going to switch to black just to be consistent with the last slide. Okay, our decision, we have two choices: reject the null hypothesis or fail to reject the null hypothesis. It says the null will fly, so we're not going to reject it. It's good, it'll fly. So we're going to fail to reject it. Time to write our conclusion. We always start with the word there. First decision, is or is not. This decision comes from our fail to, so is not. And then we say sufficient evidence. Two. Next decision, support or reject. This has nothing to do with our fail to reject from earlier or the P being high. This decision has everything to do with the very original claim, which was less than. Less than does not contain equality. It's just strictly less than, so we say support. All right, no more decisions to be made. We just write the claim that, and we restate the claim. The percentage of computers with antivirus software programs is less than 96%. Okay. I hope that made sense. Please pause the video and rewind it if you need to, as many times as you need to really focus on each step. Each step has a lot of thought that goes behind it. And if you look at our video from section 8.1, all of that thought is really spelled out if you need to refer back to that. And that will conclude our discussion on section 8.2. Thanks for joining me. See you next time.